Hello, this is the Math 100 lesson for June 9th, 2021. We're going to cover linear equations, and I'm probably going to go into the physical therapy math as well as we go through this. I'm also going to cover that not face-to-face, but when we're together. But I figured I'll get it started on this lesson, and then we'll hit a lot more of it when we're together. So without further ado, I'm going to go ahead and bring up the lesson real quick. And we're going to start with linear equations because that's the first thing we're going to start with. All right, so I have linear equations brought up now. I'm just going to move around my little video a little bit so it's out of our way. There we go. So when we're dealing with linear equations, we're going to talk about things like the coordinate plane, linear equations, then obviously graphing. That's the big thing. And again, we're not going to go into high-level graphing. I'm not going to have you be graphing on your tests or anything like that. You just have to understand the basics of it here for me. So when we have the coordinate plane, that's what you see in most common math things, right? Where you have an X and a Y axis. So you have all kinds of parts. You have the X axis. There's our X axis. We have the Y axis. We have the origin, which is where we have 0, 0, so it'd be where the y and the x-axis meet. And then we have quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This is unlike most other things that exist, because most other things that exist go clockwise. The quadrants in mathematics go counterclockwise. So you have all of the positives on the y-axis first, and then all the negatives on the y-axis. So it goes, when we're doing this, right? Positive x, positive y, negative x, positive y, negative x, negative y, and positive x, negative y for the quadrants. So quadrants 1 through 4 are kind of important. That'll actually kind of play in the fact when we start talking about quadrants of the abdomen as well. It's not that far disassociated when you think about it. So this is just looking at before. So in quadrant 1, both x and y values are positive. In quadrant 2, x value is negative, the y value is positive. Quadrant 3, both are negative. And then in quadrant 4, the x value is positive, the y value is negative. When mapping a point with the setup of x and y, you would use the x coordinate to move along the x-axis, either positive or negative, and then the y coordinate to move along the y-axis, either positive or negative. So that leads into things like linear equations. Linear equation is the equation where the graph of said equation forms a straight line. So linear equation, equation of a line. The equation is said to be linear when a constant change in x produces a constant change in y. We're also going to talk about that being the slope or the steepness of the line. There are collinear points, or points that exist on the same line. Slope is the measure of the steepness of the line or the rate of change. This is the rise versus run, which we'll talk about with wheelchair ramps. So in linear equation, all variables are to the first power. So 3x plus 12y equals 1. That is still a linear equation. But if we add a x squared in there, it's not a true linear equation anymore, because now that is the second power, not to the first power. So as long as all variables are the first power, it's a true linear equation. So the first thing you need to do is create a grid to determine the line values. So let's look here at x plus y equals 1. So we choose a selection point for either the variable and begin to create a plot. So what happens if x here is equal to -2? Well, we're going to go up and plug that in. So if we make x equal to -2, then y has to be 3. So x equals -2, y equals 3. If x is -1, then y is going to be 2 in order to equal 1. And we just keep going down that value, and that allows us to plot. This gives us coordinates on our graph that we can go through and plot to make a line. And that's kind of the point of that linear equation and the coordinated plane. So here we have a bunch of dots, and these are just following along that actual product, or that formula, that linear equation allows us to make a straight line kind of running through it, right? So we have this nice, even sloped line running right through all those coordinated points. So now that we've plotted our data points, we can draw a straight line through those points and gives us our visual representation of the linear equation. So there's our drawn straight through it, and it goes up for forever, and it could theoretically go on for forever. We could go all the way, what is x to the infinity power, or x infinity equals y, whatever infinity would be. The slope is also noted, as we talked about, as the pitch or the grade of the line, much like the grading of a hill on a roadway. It's symbolized by the Greek letter delta, as delta in mathematics and scientific symbols is a symbol for change. So it's a fancy triangle, basically. Slope is the rise and the run, the change in the x coordinates over the change in the y coordinates. So if we wanted to calculate out what the actual slope of a line is, we just have to use two different points on that line, put them into this formula, and it'll give us the slope. So let's look at our previous example, x plus y equals 1, right? So we have a whole list of coordinates here. If we use this equation, we pick out two of these things out of this list. So here we picked y2 is 3, and that means y2 is 3, what's up here. So x2 then would be -1. And then we picked y1, which we picked 2, and then we picked -1 because that's x1, those match up. So what we did was we just went up here and said, this is, get my draw thing here, x2, y2, x1, y1. We could have picked any of these coordinates that we picked, as long as we stay with the same x coordinate to go along with the same y coordinate and the same x coordinate to go along with the same y coordinate, we would literally get the same slope. So it really wouldn't matter which way we do this. When we figure this out here, right, it's going to come out to be 1 over -1. So what this is saying is for every positive change of 1 for the y value, the x change will be -1. The converse will be true as well. For every negative change of the y value, the x change will be by +1. That's how we get that line. An x-intercept on a line is the x coordinate where the line crosses over the x-axis, where y would be equal to 0. The y-intercept, on the other hand, would be the y coordinate, where the line crosses over the y-axis, where x is equal to 0. This is where we come up with this kind of slope-intercept form of the line. It's a linear equation written in the form y equals mx plus b, where m represents the slope of the line. So in this case, we have 1 over -1, right? And the line, slope of the line, and b represents the y-intercept. So this is where b would be where x is equal to 0. So you do have to know the formula. Again, I'm not going to have you convert anything into this formula, but you do have to know, if I ask you what the slope-intercept formula is, you have to know that is y equals mx plus b. Whereas the standard form of a line, which is a standard linear equation, is written in the form of ax plus by equals c, where a, b, and c are real numbers, and a and b are not both equal to 0, because if we equal both of these to 0, that would be 0x plus 0y. Well, that would just be the origin point on all of our graphs, because that'd be 0 plus 0, c has to be 0. So that would literally be, if we had our graph, that would be at our origin point here in the center. And that's not a line, obviously. So back to our previous example here with x plus y equals 1. It's already standard form, right? That's already in the standard form of ax plus by equals c. When we look at that, that's the same as saying 1x plus 1y equals 1. This is our ax plus by equals c. In order to convert that to the x-intercept, right, we have to set the y value to 0. The x-intercept would be 1. So if we make y 0, x becomes 1, x equals 1. To get the y-intercept, we set the x to 0. Again, y-intercept would be 1 as well. The slope-intercept form of the line, y equals mx plus b, where m represents the slope of the line and b represents the y-intercept. We know that the slope of the line is technically 1 over -1, or just -1, because 1 over 1 is 1. We know that the y-intercept is 1 from above. So therefore, the formula is y equals -1x plus 1. We could just as easily go up here to our other formula, where we have x plus y equals 1, and convert that, couldn't we? Because in order to get x off this side, we have to get a -x. That means we have to add a negative x to this side as well. And that would give us y equals negative x plus 1. Same as this down here. So again, the standard form, the original setup was already in. So we talked about that. So a horizontal line would be where where y equals any real number with no specific definition for x. In this case, x can be any value and there's no slope of a line. So if we say y equals 4, this is a horizontal line through the y value of 4 and can literally have any x value. So it could be x equals 1, x equals 2, x equals 3, x equals negative 50, right? As long as that y value stays at 4. A vertical line would be where any x equals any real number with no specific definition for y. Excuse me. In this case, y can be any value. There's no slope of a line. In this case, if I say x is equal to 4, is a horizontal line through the x value of 4, but literally can be any y value. So I want to go back really quick to my graph here just so I can be clear about this. So when I said that if we had a formula that says y equals 4, that is still a linear equation. That's just a linear equation that is literally going on that 4 part of the coordinate plane. Or if I did x equals 4, it'd be a linear line going straight through the, that was a really good straight line there, Mr. McKeever. Wow. It'd be a linear line going right through the 4 on that, and the y value could be whatever you want. Because there's no specification here, right? This is literally where, because remember our standard formula is ax plus by equals c, right? In this case, x is 1x, b is 0 in front of y because the y is just going to constantly change, right? Equals 4. That's kind of the way we're going to look at it. But that's it for linear equations. Again, you don't have to have a ton on that. It's not like it's that complicated. So I'm going to switch gears. We're going to talk about physical therapy math now. So this is the meat and potatoes of what you came into physical therapy for, right? So we're going to talk about some things then. So we're going to talk about goniometry. We're going to talk about angles and measurements, the rule of 8s, billing and productivity, time cards, and a little bit about insurance. So goniometry is literally broken down from the Greek of goniometron, or gonia meaning angle, and metron meaning measure. So goniometry is literally the measurement of angles. In physical therapy, this relates to the measurement of angles of the joints of the body, and can usually be seen as the measurements of either active or passive range of the joints of the body. It's the measurement of one direction at one time. So it's the measurement of elbow flexion or the measurement of elbow extension. It's not the measurement of elbow flexion and extension. You're measuring one direction at one time, right? We're just doing one direction, just like the group. So we're going to have one measurement for elbow flexion. We'd have one measurement for elbow extension. So some key terms. We have goniometer, right? The goniometer is the device we use to measure all of the joints. There are all kinds of different sizes of goniometers. Here's a standard one. Here's a finger one and another finger one that we have. So there's all kinds of different goniometers that are out there. When we have a goniometer, we have a proximal joint component. The proximal joint component is one that's going to line up along this fixed axis. We have bony landmarks. Bony landmarks are what we're going to use to measure off of as reference points. We're especially going to have a bony landmark for our vertex. And then we also have what's called an end feel, which is the overall feeling of how the joint's final position feels. So if I move my arm together into elbow flexion, right, the soft tissue of my forearm is going to impact the soft tissue of my biceps, and I'm going to get what's called a soft end feel as they kind of close together. Versus the wrist, when I pull the wrist back, I can't get soft on soft back here. But what I get is a very firm end feel because those finger flexors and the wrist flexors are pulling me forward as I'm stretching backwards. So there's a kind of standard goniometer. That's a baseline. I don't know what brand this is. This is a Salmons and Preston. I mean, there's all kinds of brands out there. So when we're dealing with this, we're going to talk about angles, right? And in the mathematic term, an angle is formed when two rays, which is two lines coming off a common vertex, right? One ray is called the initial side, the other is called the terminal side. And the measure of degree is between the initial side to the terminal side. So here we have angles and their measurements looking at it. Our vertex is this spot down here, right? And usually when we have a line, we'll label it something like this, A, B, C, where B is our vertex and BA is one ray, BC is another ray, and the whole angle is the angle of ABC. That's the mathematics, right? In physical therapy, we're going to talk about this. This initial side is going to be our fixed side. This terminal side is going to be our moving side. And this vertex is going to be some bony landmark that we use as a vertex. So it's just like I said, we have a proximal arm, the stabilized arm, we have the joint itself, and then we have the movement arm. Any angle where the terminal ray and the initial ray are at the same position means that angle would have a total degree of 0. So what this is saying is, if I have this vertex of B, and I have ray A that goes there, and that is ray ABA, and then I have another ray, and they're laying right on top of each other. This ray goes through here and here, so I have ray BC. Because they're laying over on top of each other in the same position, that's a 0 degree angle because there's no change, right? Each angle where the terminal ray and the initial ray are the exact opposite of one another would have a total degree of 180. So in this case, if I have my angles again, and it's forming a straight line, and here's my B, here's my A, here's my C, right? My angle ABC, because it makes a full 180 degree arc, the measurement would be 180. A 90 degree angle is one that forms a right angle or comes into right degree. So here we have an angle that kind of looks like this. Right? That would be a right angle where it forms 90 degrees. Most of the geometric shapes that you think about, like a square or a rectangle, have right angles in them. They can also be used in many theorems in mathematics, right? We've all seen the Pythagorean theorem where we have A, B, and C, and where we have A squared plus B squared equals C squared, right? On a right angle triangle. I hope we've all seen that at least. Angles, again, are typically written in that form ABC, where A is either the terminal ray, B is the vertex, C is either the terminal ray or the initial ray. Letters don't have to remain the same, but it can be any combination of 3 letters. ABC is just kind of the typical norm. Supplementary angles are 2 angles, the sum of whose measurement is 0. Each angle is the supplement of each other. So what this is saying is, if I have an angle that looks like this, so here's B, C, there's A. And I also have another angle that goes up like this, and this is D. So in this case, I have angles A, B, C, and I also have angles D, D, B, C. If you add both of those angles together, they're going to equal 180 degrees because it's a straight line. In that case, those angles are supplementary. If the same 2 angles form a right angle there, they would be considered complementary. So if they form a 90 degree spot, they're complementary. And the way I always think about that is, if you're right for each other, you complement each other. Oh, isn't that cute? But if you form a straight line, you guys supplement each other. You supplement to form one straight line. When we have a line that intersects a pair of when we have a line that intersects a pair of lines in a plane, is a transversal of those. So if I have 2 lines that are going straight across, and I have a line that comes down through them, that is called a transversal line or transverse line. that actually forms a bunch of different angles, right? I have angle A, B, C, and D. And I also have E, F, G, and H. And there are some math theorems that are built off of that. But that's just knowing that if a line crosses through two other lines, it's the transverse of those lines. In protractor goniometry, we say ABC is an acute angle if ABC is less than or equal to, or actually just less than 90. So right angle if it's at 90, and it's an obtuse angle if it's greater than 90. So I always think if somebody's obtuse, they're kind of grumpy. So usually greater than 90. Again, we know that if they're supplementary, it means they're going to add together to equal 180. If they're complementary, they'll add together to equal 90. So why do we have these theorems? We have a sum of theorem. We have a sum theorem here that says the sum of measurements of all the interior angles of a triangle is 180 degrees. So what is this saying? I don't have a triangle. How about that? Let's draw a triangle, I guess. So if I draw a triangle, if you add all of these interior angles up together, they will equal 180. So all angles equals to 180. This can be really important, and it's kind of a formulation of a lot of the math we do when we're talking about geometry and stuff like that. Because a lot of times we'll have something like this, and we can use tangents and cosines to come up with the angles and stuff like that. I'm not really worried about with you right now. But let's say this angle up here is 20 degrees, and we know this one is a 90-degree angle. Well, 20 plus 90 is 110. So that means we would know that this angle down here would be 60 degrees, even though it's not drawn properly to scale. So all the angles in the inside of a triangle are 180. The sum of the measurements of the exterior angles of a convex polygon is 360. That makes sense, but it's a little complicated to think about. So what it's saying is, if I have a square, for example, where I have 90, 90, 90, and 90, right? I add all my exterior angles up. All of those exterior angles will eventually add up to be 360. So the sum of all the exterior angles, one at each vertex of a convex polygon, would be 360. It's just a theorem I need you to know. That's it. So when we're using stuff like this in math or in this class or in school, instead of using a protractor, which is what we use in regular mathematics, we're going to use goniometer. Right? The goniometer has the fixed arm, which I talked about, and movement arm, and a vertex to rotate around. When measuring angles in goniometry, you place the fixed arm along the initial ray. So in the case of measuring shoulder flexion, I'm going to put it along my elbow flexion, I'm going to put it along my humerus, and then place the movement along in the terminal ray, the part that's going to move. You don't have to know the bony landmarks for this, so don't worry about that. We'll get into that in kines. And the vertex, in the case of elbow flexion, would be the lateral epicondyle of the humerus. That gives us a vertex to rotate around. A good clinician can eyeball an angle without having to measure it. Now, this is not actually measuring. This is knowing about what you have. This can be useful in gathering rough data or determine if you've made any progress with the patient through stretching, or if you think you're going to screw something up. Because again, on these goniometers, there are so many numbers. And if you're testing my elbow flexion, and you have me flex my elbow, and you're like, oh, well, it looks like, so there's 0, there's 90, I go a little bit past 90, so I'm about 120. But if you're reading your goniometer and you have it's at 120, so let me get that to 120 here. And you're like, oh, well, it says 300. You got 300 degrees of elbow flexion. You've read off the wrong number on the goniometer, right? That's why it's important to be able to estimate and go, oh, it's about 120. Look what you get on your goniometer and see if it matches up. So let's work on a couple things here together. So what would be in a joint that would be less than or equal to 90 degrees of motion? There's a bunch of them in the body. Well, let's think. The wrist flexion, wrist extension would be one of them. Pretty much all the finger joints, right, are going to be about that. What about joints that have greater than 90 degrees range of motion? Well, shoulder flexion, that's about 180. Shoulder abduction, about 180, right? Hip flexion, it's going to be at 120. Elbow flexion, about 130. So there's all kinds of joints out there that either are equal to or less than 90 or greater than 90 in motion. The only joint that reaches 180 degrees in the human body is the shoulder in flexion and abduction. All the other joints will be less than 180 degrees. All right, so let's change gears here totally. Let's talk about billing. In PT, one of the most important things you'll be doing post-treatment, besides accurate documentation and following up your PT, is billing. Why do I say that? Well, the specifics of billing itself will be covered in other classes. We're going to talk about a very basic rule here called the Medicare Rule of 8. The Rule of 8 applies to all time-based codes, not to untimed treatments. This really won't make sense to you right now, but if you understand this now, it will help you in the future when you actually do understand it. Medicare itself governs all of our policies that we do pretty much. They are our largest provider as far as therapy care. They provide the most consistent insurance coverage for most of our aging population and also disabled population. So they kind of set the rules. So each billable timed unit in physical therapy is 15 minutes long. Therefore, in one given hour, you can have 4 billable units. 4 times 15 equals 60. That's an hour. There are other rules regarding concurrent treatments, group treatments, untimed codes. That's not now. Some of you, I can already probably are thinking about this if you've been a tech before, like, well, I've seen them bill. No, don't worry about that right now. We're just talking about one-on-one timed codes. This is important for billing. So it's important to understand there are 4 billable units in every hour. So here's how the Medicare Rule of 8 works. Medicare states that for time-based code, a clinician must provide at least 8 minutes of direct patient care in order to qualify for the first 15-minute unit. So if I want to bill 1 unit for the patient, I have to at least spend 8 minutes. I can spend the whole 15, but if I spend 6, I can't bill for it. If I spend 7, I can't bill for it. I have to spend a minimum of 8 to bill for it. If I want to get to 2 units, I have to fulfill my full first 15 minutes to get that first full unit done. And then an additional 8 minutes of treatment time. So I would have to get to 23 minutes. To get to 3 units, I would have to complete 2 full 15-minute brackets. So 30 minutes and an additional 8-minute bracket. So 38. So in the bottom here is in order to get 2 units, I have to spend 15 minutes plus 8 minutes, which adds to 23 minutes. So looking at these, we talked about this is the Medicare rule. So when we have 1 unit, it's between 8 and 22 minutes. At 23 minutes, we go to 2 units. That goes to 37 minutes. 3 units goes 38 to 52. At 53, we go to 4. 53 to 67 is 4 units. 5 units starts at 68. If you're starting to get into 5, 6, 7, 8 units, you're spending a lot of time with the patient. You rarely get that. Most of the time, it's 2 units is what you get. So how much time would a clinician have to spend minimally to get 2 units? Well, in order to get 2 units, we have to do 1 full 15-minute session. And we have to do 1 8-minute session. Well, again, not a session, but just kind of thinking about it that way, for a total of 23 minutes. To get the 5 units, we would have to do 4 full units of time. So 4 full before that. And the 5th one we can do for 8 minutes. So that would be 68 minutes. How to get to 3 units? Well, 3 units, we have to have 2 full 15-minute brackets. And then we can add 1 more 8-minute bracket. That would be 38 minutes. 19 units. Well, to get to 19 units, we'd have to do 15 minutes times 18. We'd have to go 1 unit short there, right? And then add 8 minutes to that. So in that case, get my little calculator up here because I didn't have it up. Of course. So 15 times 18, 270 plus 8 minutes. So in order to get this, we would have to have 278 minutes total. So no matter what you're doing, if I was to say 6 units, how to get 6? Well, you'd have to have 15 minutes times 5, so 1 unit short of those 6 minutes, and then add 8 minutes to it. That's kind of the math. So if I was looking at this, if I wanted to put this in kind of a math theorem way, and I said that the number of units I want to bill for is Y, my formula to calculate Y would depend upon what I'm doing. So I would say that Y minus 1, right, times 15 plus 8 gives me my time. That would be a formula for this. So even if we said that we wanted to bill 1 unit, right? So 1 minus 1 is 0, 15 gives me 0, so I need 8 minutes to get there. If I wanted to bill for 10, I'd go Y minus 1, so I have 9 here, 9 times 15 plus 8. So if you're looking for a formula, that's a formula for it. But if you just can do the math, it's not that difficult. You're never going to get 19 units, 20 units, stuff like that. So don't totally freak out about that. Here we have time-wise. So what happens when we have time? Well, I'm going to look at subtracting out minutes, right? So in the case of 23 here, I'm going to say, okay, well, 23 minus 15, that's 1 unit, equals 8. Well, 8 is 1 more unit. So I have 1 unit there, so that's 2 units. We'll do the rest of these when we're in person, just because I think this is probably the hardest way to calculate it. So I want to do this in person. We'll do that on Monday, so don't totally freak out yet about this. The lesson to be learned here is to always be aware of where you are with your patient and time and how many minutes you've spent with them. Sometimes spending a little bit as 1 minute more or 2 minutes more can increase your units by an additional unit. That comes into play when talking about the productivity. Next slide, Mr. McKeever. Yes, sure thing, Mr. McKeever. So many companies have productivity goals in place for PTAs. And what these goals are is based upon the total number of time a clinician works for the day versus how many units they've billed. For every hour a clinician works, they can have a possible theoretical count of 4 units, right? 15, 15, 15, 15, 60 minutes. In an 8-hour day, that means theoretically you have the potential for billing 32 units, or 8 times 4, right? 8 times 4 units equals 32 units. Some hospitals will require 100% productivity. That means you have to get 32 units every day if you're working 8 hours, but most of the time you don't. So if a company says you must be 90% productive for a day, it means you have to bill, you have normal possible 32 units, right? 32 is 8 times those 4 units. So you have possible 32 units. To get 90% productive, we have to multiply that times 0.9 using that percentage class we had before, right? And so 0.9 times that is about 28 units. Will get you safe for the day. This seems counterintuitive as putting as a hard number on your production, right? But in a company's mind, there has to be a fiscal goal in place, or otherwise people will just abuse the system and not see patients or not bill properly. So if a clinician works 10 hours per day and has a 95% productivity goal in place, what does that mean the clinician has to do? Well, we know the clinician works 10 hours a day, right? And we know that we can do 4 units per hour. So we're going to go that we can have a total of 40 units. Now the clinician wants to be 95% productive. So we multiply 40 times 0.95, right? So we multiply 40 times 0.95. Let me get my little calculator back up here again, just so I have it exactly accurate. 40 times 0.95. That means in that day, the clinician will have to see enough patients to hit 38 units. If they don't hit this 38 units, then they're not being productive and they may encounter negative consequences for it. So this comes to the timesheets. This is the timesheet that PIMA is required. We are going to a digital timesheet. So by the time you guys go out on clinicals, this timesheet may be obsolete. When you're on your clinicals, no matter how many weeks you have, so if you're on a 2-week clinical, let's change that color. That's kind of fading in there. If you're on a 2-week clinical, you have to do 40 hours per week. So at the end of that 2-week clinical, you have to have a total of 80 hours. If you're on a 7-week clinical, you have to have 40 hours each visit. So that's going to be 280 hours. Dr. Ovreskin will explain all this to you. But in the case of this sheet here that we have, right, you have to make sure that you circle which practicum you're in, what week you're in, put your dates here. So in this case, today, I said is the 9th, right? Something like that, if I remember correctly. Yeah, today is the 9th. Yes, Wednesday the 9th. So we'd come in here, we put 6/9, 6/10, 6/11, 6/12, 6/13, 6/14, 6/15. That's a 15, honest, I promise. We're going to come down here and put the total number of hours we did. So if we did 8 hours on Wednesday, 8 hours on Thursday, 8 hours on Friday, and then we did 8 hours Monday and Tuesday. Again, we don't get paid for lunch. We don't get paid, period, but we don't get credit for lunch. If we did 5 days at 8 hours, we'd have 40 hours, right? Then we'd add up any of the total hours we're at to make sure that we're meeting it. So if we already had we're in this case, we're at week 1, we'd only have 40 hours at that point. If we're at week 4, we'd have to add up all of our previous hours. Important thing here is when you're done, you have to sign your student signature and your CI must sign it and date it. Do not fraudulently sign your forms. We will know about it. And Dr. Ovreskin has said, we'll go over this more in depth. Especially paper ones, time cards are going away, right? But working on clinical rotations and working for staffing agency often requires completing a time card, especially if you're doing something like home health. They always start with the day of the week. The rotation starts for the company payroll. For our program, that week is Wednesday and it runs till Tuesday. The time card will be needed to be uploaded to Dr. Ovreskin weekly in Blackboard. It will require you to have your typed or printed name, your cohort number, your clinical rotation site, your clinical instructor signature or signed name, your practicum number, all that fun stuff. So you need to have all of that filled out. What I would suggest to you on the first day of your clinical is set up timesheets for all of your weeks that you're going to be at clinical. That way you can make sure you have week 1 signed as soon as it's done, week 2 signed as soon as it's done, 3, 4, 5, 6, 7, whatever you need to do. Like I said, your total time for the clinicals will vary, but you will need to have 40 hours per week. If you work 4 10s, that's 40. Some clinics will make you work 4 days at 8 hours and then 2 4-hour days. So you actually work in 6 days per week. Whatever you need to hit 80 hours. If you are short, you will need to make up those hours. If you miss a day, which you are not allowed to do, you must make those up. You do not even get time off for holidays out of those hours. So if your clinic's not open on Thanksgiving, you're still required to get 40 hours for that week. That's not our rule. That's Department of Education rule. We cannot get around that. So that leads us into compensation. So once you graduate, obviously compensation is going to be the big thing. Compensation is big, but one thing we don't talk about a lot when we talk about compensation, we talk about hourly rate. We don't talk about total compensation. Total compensation is the entirety of all monies paid to you by your employer in various manners. It includes your salary, which is usually your hourly rate. Any bonuses, ha ha ha, I never see those. Vacation time, woohoo. Any paid sick time. Benefits, 401k match, or continuing education. Excuse me. The reason I'm talking about this is because maybe a job might not pay the best in salary, but man, if their benefits are awesome, it may be worth taking that job over another job. So why do we talk about this math? Because when you graduate from school, you may not get the exact salary you want. Salaries based upon many things: the setting, the caseload, total compensation, travel time, and other perks. Obviously, we'll talk about it, but some facilities pay more, right? SNFs typically pay a little bit better when an outpatient pays a little bit less. So let's look at an example here. So job A offers you an hourly rate of $35 an hour, benefits fully paid by the employee. So meaning you have to pay everything, no matching 401k, and 2 weeks of PTO, no continuing credit for education, because we have to fulfill 15 hours of continuing education every year. But then job B comes in and says, hey, I'm going to only pay you $25 an hour. Seems a little bit less, right? But they're saying, I'm going to pay most of your benefits, 75%. You only have to pay 25% of your benefits to your health insurance. We're going to give you 100% match on your 401k up to 6% of your investments, 2 weeks of PTO, just like the other job, and you're going to get $3,500 from us for continuing education. You look at these two jobs and you just look at their hourly rate. Well, the second one looks worse, right? $35 an hour after 40 hours, $1,400 per week. 25 times 40 is about $1,000 per week. But man, let's not forget about those benefits, right? Because they're not all clinics are the same when it comes to this, right? So we're just going to say all the benefits, medical, dental, life insurance, ADD, so accidental death and dismemberment, say that both clinics cost $250. So if you figure those benefits into gross, right? So $1,400 minus $250, because you're paying everything per out of that paycheck, well, that's $1,150 gross. Well, if the other one, you're only paying 25%, you're now at $937.50. So job A still comes out a little ahead, right? But you forgot about the fact that with job B, you get $3,500 a year on CCU, which you're talking there, another monthly about $290. So now job B is at $1,200. And that's before you figure in the 401k, right? So in the case of, say, 6% of $1,000, $60, but your employer matches 100%. So for every $60 you put in, your employer's putting in $60, you get $120 put in your 401k. What I'm trying to get at here is don't purely think of your rate that you get paid. Look, if you learn nothing else, the whole picture needs looked at. And again, this is something that we used to learn back in school. We were taught it when I grew up, but I don't think we talk about this anymore. Total compensation is something we kind of ignore. And so you really have to pay attention to it. If you just want the hourly rate, then just take the hourly rate, but understand you're probably going to pay something else on the back end if you get a higher hourly rate. Switching gears a little bit again, now we're going to talk about insurance. And again, we're going to go over all of this again, this whole lecture here. I'm just kind of prefacing it, and then we'll go over it again together. So don't totally freak out again. We're just going to talk about different types of insurance and that, but insurances are mainly covered in semester 5. You do need to understand the basic maths of insurance. You need to be careful when talking to your patients about their insurance and always speak in generalizations, because if you quote something, they will hold you to it. Following information is just rudimentary explanation of insurance costs. So you have your insurance plan costs. This is the amount you have to pay monthly or yearly, depending on how you pay it, to have the privilege of being insured by a provider. And I'm going to go probably many times as we go through this program talking about the privilege of having insurance, because reality, it should be a right, but we're not going into that right now. In the United States, the average is $450 for an individual, $1,200 for families. If you're unemployed, on average, US full-time employers, or if you're employed, the average full-time employer pays 25% of that cost on average. The UCR, or the usury, customary, and reasonable, is a rate that is negotiated between the insurance company and the provider for their service. So every provider theoretically could have a different UCR. If you go to physical therapy and they charge $250 a visit, ABC Insurance will contract with that clinic and say that, I know you're charging $250, but we're only going to reimburse you $125. And if you had no insurance, you'd pay $250, but the insurance is only going to have to pay $125. Typically, providers will take less UCR if the insurance has a greater chance of sending them more patients. So if you have a company that takes more patients from that insurance provider, oftentimes it'll be a lesser rate because they're going to get volume. There is a thing called a deductible. This is the amount of money you must pay before your insurance provider pays anything. This used to be $0. Like growing up, I never had a deductible. We never heard of this. But now it's only gotten higher and higher each year. Right now in the United States, the average deductible is $4,500 for an individual, one person, $8,500 is family. That means you have to pay out of pocket either $4,500 or $8,500 before your insurance pays anything for you. Think about that for a second. To me, that is just bonkers, right? Based on those average, you would not pay anything until you have paid that out of your pocket. Let's say you and your significant other, right? If you have you and your significant other, the insurance pays anything for you, you'd have to spend $4,500, but before it pays anything for your significant other, you have to spend up to $8,500. So before that, you're paying everything out of pocket on top of paying your monthly payments, on top of paying anything else, your pills, stuff like that. Your out-of-pocket maximum is the maximum you would have to reach before you stop paying for any of your healthcare costs. This typically eliminates any copayment, co-insurance costs, or anything like that. In the United States, that has an individual mandate and a family mandate. The individual mandate is about $8,800. Family mandate is $1,600. Once you hit these, theoretically, you would not have to pay another dime for healthcare. But there are ways for insurance companies to get around this and still require you to pay some of your care. There are loopholes to the out-of-pocket maximum. A copay is typically a flat fee that is required to be paid by you for an office visit up to you hitting your out-of-pocket maximum. It's usually broken down into primary care, specialist care, urgent care, and emergency room. In the United States, the average is about 25 for primary care, 50 for specialist, urgent is about 100, and emergency care going to the emergency room is about 300. So if you get sick and go to a normal doctor and network, assuming you've met your deductible, you'd only be responsible for about a $25 payment. Coinsurance is much like a copayment, except it acts as a percentage of the UCR instead of a flat fee. Sometimes this can be cheaper unless you consistently have medical visit. Myself, I typically try to go for a plan with copayment because I have quite a few medical visits. But maybe if you don't have a lot, maybe coinsurance is the way to go. The average in the United States right now, again, is about 25% coinsurance. So let's say your doctor office charges $25 for a simple visit. Your insurance would be 25% of that, or $25 if your deductible is met. If your deductible is not met, you may have to pay that full $100 until you reach your deductible. Typically, coinsurances don't go up as you step in levels of care, primary care to specialist, but each insurance carrier will vary. So let's look at something. Here you have ABC Insurance. You pay $500 a month for your insurance. You have a $4,000 deductible. You have a $9,000 out-of-pocket max and a 15% coinsurance. You start off the year going to PMI Physical Therapy Clinic, which is in network for ABCI. Your UCR for the PT visit is $135. At the end of your visit, you would typically pay the 15% coinsurance, or $135 times 0.25. So that's about $20.25. But because you haven't met your deductible for the year, you're responsible for that full $135, right? So even if you pay that $20.25 to the clinic, you're eventually going to get a bill for that full remainder amount. You would not get to pay the $20.25 until you've fully paid $4,000 out of your own money for the full year. So if you think about it, you'll pay $6,000, right? Your actual monthly payment, so 12 times 500, plus $4,000, your deductible, your coinsurance is right, for a minimum of $10,000 every year for your insurance. You would not stop paying your coinsurance until you've hit $9,000 out of pocket maximum, and by that point, you would have paid $15,000 on your own. And to get there, you'd have to pay the difference in coinsurance between the deductible and out-of-pocket maximum, or there's about another $5,000 in coinsurance. If you figure on the U.S. median income of $60,000 for just base cost, the cost plus deductible, you're talking that you're paying about $10,000 of your annual income for insurance. These are the things that people do not think about when we talk about universal healthcare. And this is not me preaching about it. Please, I will preach later. This is not me preaching about universal healthcare right now, because most people think your tax rate's going up. On average, if we go to universal healthcare, it will raise your tax rates by 7%, or about $4,270 per year. But that would eliminate your deductible and your monthly cost of insurance. You'd still have a copayment, but on average right now, Medicare copayments are about $15. Just some food for thought there. And again, I will hit this more when we talk insurances and stuff like that. All right, fantastic. That is actually both the lectures. And again, I'm going to hit that second lecture again when we are together. I wanted to preempt it a little bit, but we'll talk more about that when we're face-to-face. There is going to be no homework assignment for this. So there's no form assignment. There's nothing like that. You have quizzes to complete. So please work on those quizzes. They are due by your midterm. We will review for your midterm, so don't totally freak out about that. And midterm is a misnomer. It's really just your math final. It's just a big math test. And we will review before you do that. So other than that, I just want to wish you guys a good day. I've probably already seen you in anatomy by the time you're watching this. I don't think any of you are going to be watching this in the middle of the night. Some of you may watch it before you come in. But if you did, fantastic. I hope you enjoyed it. If not, well, I still hope you enjoy it. But I will see you in anatomy tomorrow, today, or whatever it is. Other than that, have yourself a great day.